three-way handshake is like two kids shaking hands before they start playing a game together. The first kid client says, "I want to talk." The second kid server replies, "Okay, I am ready too." And finally, the first kid says, "Great, let us start." This three-step dance makes sure both sides are awake listening and agree on the rules before any real data is sent. Without it, one side might send a message that the other never heard, just like trying to play catch when one person is not paying attention. Each step of the handshake is a special packet, a little envelope with a label called flag and some extra info. SYN, which stands for synchronize, is the first envelope. It says start and carries a random number called ISN, initial sequence number. SYN ACK is the second envelope. It says got you start too. It contains the server's own ISN and acknowledges the client's ISN +1. ACK is the third envelope. It says all set and only acknowledges the server SISN +1. In the TCP header, the flag bits SYN and ACK are set to 1 for those meanings, while other flags stay 0. The header also carries source and destination ports, window size, checksum, and the two numbers sequence and acknowledgement. Think of the sequence number like a page number in a storybook. The client picks a random first page number, say 1000, and puts it in its SYN. The server says, "I received page 1000, next page should be 1001, by putting 1001 in the ACK field of its SYN ACK. The server also chooses its own first page, say 5000, and puts that in the SYN part. When the client receives the SYN ACK, it replies with an ACK that says, "I got page 5000, next page is 5001. Client_sec equals ISN_C, server_sec equals ISN_S, client_ACK equals ISN_S +1, server_ACK equals ISN_C +1. These numbers become the starting points for all later data packets, so both sides know exactly where to continue reading and writing. Explanation:(TCP) can be drawn as a state machine, like a board game with squares you move through. The main squares are :closed arrow SYN dash, sent arrow SYN dash, received arrow, established arrow, fin dash, wait dash, 1 ... and many more for closing. The transition table looks like : row 1, current state closed, event active, open, send SYN, new state SYN dash sent. Row 2, current state SYN dash S end, event receive SYN dash ACK, new state established. Row 3, current state SYN dash received, event receive ACK, new state established. Row 4, current state established, event close request, new state, fin dash, wait dash 1. Row 5, ellipsis. Each arrow shows what packet triggers the move, just like rolling a die moves a token on a game board. The diagram ensures both sides follow the same path so they never get lost. RTT, round trip time, is the time it takes for a packet to go to the other side and come back, like shouting hey across a valley and hearing the echo. TCP measures RTT by noting the time it sent a segment and the time it receives the CK for that segment. The measured RTT sample is used to compute the retransmission timeout RTO with the formula SRTT equals 1 minus alpha times SRTT plus alpha times RTT sample, alpha approximately 0.125. RTTVAR equals 1 minus beta times RTTVAR plus beta times absolute value of RTT sample minus SRTT, beta approximately 0.25. RTO equals SRTT plus 4 times RTTVAR. If an ACK does not arrive before RTO expires, TCP assumes the packet was lost and retransmits it, just like yelling again if you did not hear the echo. The timer is reset after every successful ACK, keeping the communication lively but not impatient. When the connection starts, TCP pretends it has a tiny pipe that can hold only one segment. This is the initial congestion window. CWND equals 1 MSS maximum segment size. The slow start threshold SSThresh is a hidden mark that says when CWND reaches this size, we stop growing fast and become careful. Each ACK that arrives doubles CWND equals CWND times 2 until CWND is greater than or equal to SSThresh. Then growth becomes linear CWND equals CWND plus MSS per round trip time. In plain terms, TCP starts by sending a small amount, watches the road for traffic jams, and speeds up quickly, while the road looks clear, then slows down to a steady cruise when it thinks the road might get crowded. A TCP connection is identified by 4 numbers, called the 4-tuple: source IP, source port, destination IP, destination port. Think of it as a unique address on a street, the house number IP, the room number port. 2 different apps on the same computer can use different source ports, so even if they talk to the same server IP port, the 4-tuple stays different. Binding is the act of reserving a port number for an app before it can listen. The operating system makes sure no 2 apps bind the same port at the same time, just like a landlord does not rent the same apartment to 2 people. A SYN flood is like a mischievous kid who keeps knocking on the door sending SYNs, but never steps inside. The server saves a half-open state SYN received for each knock using up memory. If enough knocks arrive, the server runs out of room for real guests. SYN cookies solve this by not storing any state. Instead, the server encodes the needed information, client IP port ISN, a secret key, into the sequence number of the SYN ACK. When the client later sends the ACK, the server can decode the cookie and know the original request without having kept any entry. It is like writing the door code on a slip of paper and giving it to the visitor. The host can verify the code later without remembering the visitor beforehand. TCP Fast Open (TFO) tries to skip the waiting room. In a normal handshake, data cannot be sent until the 3-step dance is over. TFO lets the client attach a small amount of data to the very first SYN. The server, if it has seen this client before and trusts the cookie, can process that data immediately, cutting off 1 round trip. Other optimizations include TLS 1.3's 0 RTT, which similarly lets encrypted data travel with the first handshake packet. The idea is like handing over a birthday present at the door while you're still shaking hands, instead of waiting until you're fully inside the house.